Hello everyone. Let's discuss examples of photochemical halogenation. So first we take methane. Methane is CH4 carbon is surrounded by 4 hydrogens here. So this methane on photochemical chlorination gives mixture of haloalkane by gradual replacement of hydrogen with the help of chlorine. Like if one hydrogen is replaced, then we have CH3Cl. If two hydrogens are replaced, then we have CH2Cl2. And if three hydrogens are replaced by chlorine, then CH3. And finally, if all the hydrogens are replaced, then we have CCl4. So photochemical halogenation of methane forms a mixture of haloalkane. Photochemical halogenation is not a suitable reaction for the preparation of haloalkane. Why so? Because mixture of haloalkane obtained as a resulting mixture has comparable boiling point. So a separation technique has to be used to separate a particular product. This increases the cost of a process, and along with this, as we have a mixture of haloalkane, so the percent yield of a particular product will be less. That's why it is not an economical process for the preparation of for a particular haloalkane. Photochemical halogenation of ethane. Ethane, its molecular formula is C2H6. It has 6 hydrogen here in its molecular formula, and all these 6 hydrogens are identical. All 6 hydrogens are identical. It means they show the same kind of environment. And when we do the photochemical chlorination of this ethane, then we get single monochloride here. Single monochloride. Let's take another example. Propane, its molecular formula is C3H8. It has 3 carbons and 8 hydrogen in its molecular formula. So first of all, what we do, we arrange all the 3 carbon atoms in a straight line and then satisfy the tetravalency of each and every carbon with the help of hydrogen. So CH3, CH2, CH3. Now, to check the surroundings of each and every carbon, what we do for this, we just write numbers for each and assign number for each and every carbon, like 1, 2, 3 randomly. So let's check the surrounding of first carbon. If we just check the surroundings of this carbon, to our left hand side, we don't have any element, but toward the right side, we have CH2, CH3 here. So we simply label it as A carbon. Now switch to the next one. Second carbon, toward the left hand side we have methyl CH3 group, and right side we also have a CH3. So if we check the surrounding of first and second carbon, that is entirely different. So we label it as B carbon. Now move to the next carbon, third carbon. If you just check the surrounding of this carbon, toward the right hand side we don't have anything. No element is present, but toward the left hand side we have CH3, CH2. So the first and the third carbon, they show the similar type of surrounding. They have a similar types of surrounding. So we label it as A. So it means out of 8 hydrogens, 6 hydrogens are of same type, A type of, and the 2 hydrogens are of different type, B type of. It means when you do the photochemical halogenation of propane, then 2 monochloroderivatives will be formed here. One by the replacement of A type of hydrogen, like this one, and the another by the replacement of B type of hydrogen. Let's discuss about butane now. Its molecular formula is C4H8 and two structural isomers are possible for butane: N-butane, a straight chain of 4 carbon atoms, and isobutane, a straight chain of 3 carbon having 1 methyl branch here. So first we discuss about N-butane. N-butane means normal, or you can say a straight chain of carbon atom. So we have 4 carbons here. First of all we write all the carbons in a straight line and then satisfy the tetravalency of these carbons with the help of hydrogen. Like we know this, terminal carbons are always methyl CH3 and the non-terminals are methylene CH2 carbons. So we have CH3, CH2, CH2, CH3. Next step is to label the carbons. Like we randomly assign numbers here 1, 2, 3, 4. And the next step is to check the surroundings of each and every carbon just to find out the type of hydrogen present in a given compound, because with the help of that we are able to predict the number of monochloro derivative it has. So let's check the surrounding of first carbon. Toward the left hand side it doesn't have anything, and toward right hand side it has CH2, CH2, CH3. So we label it as A type of carbon. Now switch to second carbon. If you just check the surrounding of the second carbon, toward the left hand side it has CH3 and towards right hand side it has CH2, CH3. It has different surrounding than that of the first carbon, so we label it as B type of carbon. Then move on to the third carbon. Toward the left hand side it has CH3, CH2 and toward the right hand side it has CH3. So if you just check the second and the third carbon, they show the same kind of surrounding. They have the same kind of surrounding. So we label it as B type of. Then move on to fourth carbon. If you simply check the surrounding of this carbon, toward the left hand side it has CH3, CH2, CH2 and toward the right hand side it doesn't have any group. And the first and the fourth carbon, they show the same kind of surrounding. So we label it as A type of. So it means out of 8 carbons, 6 carbons which are of A type, they show the same kind of behavior, and the 4 carbons which are of B type, they show the different kind of behavior other than the A type of. So when you do the photochemical halogenation of this compound, so in this case, two monochloro derivative will be formed, one by the replacement of A type of hydrogen by the halogen and the other one by the replacement of B type of hydrogens by halogens. So here we have two monochloro-bromo derivative. Isobutane is a structural isomer of butane. It has one methyl branch like CH, CH3, CH3. We can write it like this, or you can write it like, as all these are identical environment. All these 3 methyls have identical environment, so you can also write it like CH3 thrice CH. So in case of isobutane, these hydrogen, they show the same kind of environment, are of similar type of, and this CH carbon show the different type of environment. It means if we do the photochemical halogenation of this isobutane, then total 2 products will be formed here. One by the replacement of A type of hydrogen and the other one by the replacement of B type of hydrogen by halogen. Pentane. Its molecular formula is C5H12 And three structure isomers are possible for pentane and pentane, straight chain, isopentane, 4 carbons in a straight line, and the fifth carbon having a branch here. And the neopentane, 3 carbons in a straight line and 2 branch. Simply as we move from N to iso to neo, in each and every successive step, there is an increase of one methyl group. So N-pentane, all the 5 carbons in a straight line. Isopentane, we have one methyl branch here. And in case of neopentane, we have 2 methyl branches. So let's start with photochemical halogenation of N-pentane. So N-pentane is CH3, CH2, 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 CH3. We write the number to check the surrounding of each and every carbon. We assign number to each carbon. So let's check the surrounding of first carbon. Toward the left hand side, we don't have anything, and toward the right hand side, we have CH2, 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 CH3. So we assign it as A type of carbon. Then second carbon, towards the left hand side we have CH3, and towards the right hand side we have CH2, CH2, CH3. So the environment of first and second carbon are entirely different. So we assign it as B type of carbon. Then switch to the next one. Third carbon. Toward the left hand side we have CH3, CH2, and toward the right hand side we also have CH2, CH3. First, second, and third, if you just simply check the surroundings of these three, entirely different. So we assign it as B type of. Then switch to the fourth carbon. Toward the left of this carbon, we have CH3, CH2, CH2, and toward the right hand side, we have CH3. So this second and fourth carbon, they show the same kind of surrounding. So we assign it as B type of. Then switch to the next fifth carbon. Toward the left hand side, it has CH3, CH2, 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 and toward right hand side, it doesn't have anything. So if you simply compare, then the first and the fifth carbon show the same kind of surrounding. So we label it as A type of. It means out of 12 hydrogens, if you just check, then 6 hydrogens are of A type of, 4 hydrogens are of B type of, and 2 hydrogens are of C type of. It means if you do the monochlorination or bromination of this compound, then the total 3 monohalo derivative will be formed here. One by the replacement of A type of hydrogen, other one by the replacement of B type of hydrogen, and the third one by the replacement of C type of hydrogen. So in N-pentane, the total number of monochloro derivative will be 3 because it has 3 types of hydrogen. So if you do the monohalogenation of this compound, if you do the halogenation of this compound, then the total number of products formed will be 3, like 1 by the replacement of A type of hydrogen. Just remove the one hydrogen from the A and then put Br over there. Another one by the replacement of B type of hydrogen, and the third product by the replacement of C type of hydrogen by halogen. So total 3 products will be formed. So let's check the total number of products formed in case of isopentane. So for this, first what we do, first of all, we label the carbon as 1, 2, 3, 4, and then check the surrounding of each and every carbon. So let's start with the first carbon. Toward the left hand side, it doesn't have anything. And the toward right hand side, it has CH, CH2, CH, this type of group. So we label it as A type of. Then second carbon, toward the left hand side, it has CH3, and toward right hand side, it has CH2, CH3. Again, the first and second carbon show the different kind of environment, so we label it as B type of. Then switch to the third carbon. Toward the left hand side, it has CH3, CH, CH3, and toward right hand side, it has CH3 type of environment surroundings. So we label it as C type of. And then the next one, fourth carbon, toward the left hand side, it has CH3, CH, CH3, CH2, and toward right hand side, it doesn't have anything. So again, if you just compare the surroundings of first, second, third, and fourth, the fourth carbon entirely show the different surroundings. So we label it as D carbon. So it means out of 12 hydrogens, 6 hydrogens are of same kind, A type of. 1 hydrogen is of different type, B type of, we labeled it. 2 hydrogens are of same kind, we label them as C. And the 3 hydrogens, they show the similar kind of environment surroundings, so we label it as D. It means if we do the monohalogenation of this compound, then total 4 monochloro or monohalo derivative will be formed here by the replacement of A, B, C, and D hydrogen. So when we do the halogenation of isopentane, then the total 4 products will be formed by the replacement of A, B, C, and D type of hydrogen with the help of halogen. So let's replace the A type of hydrogen. So we have CH3, CH, CH2Br, CH2, CH3. First monohalo derivative. Second, we form by the replacement of B type of hydrogen. So we have CH3, C, CH3, CH2, CH3, and here we have halogen. Third product by the replacement of C type of hydrogen with the help of halogen here. And the last fourth product will be formed by the replacement of D type of hydrogen with the help of halogen. So by this way, total 4 products will be formed by the photochemical halogenation of isopentane. Neopentane. In case of neopentane, all the 12 hydrogens are identical. It means all the 12 hydrogens, they show the same kind of environment. So when you do the photochemical halogenation of this neopentane, then a single monochloride will be obtained by the replacement of hydrogen here. So finally we conclude, suppose a compound having a molecular formula C5H12 and its 3 isomers are N-pentane, isopentane, and neopentane. Then the total number of monohalo derivative in case of N-pentane 3, in case of isopentane 4, and in case of neopentane single monohalo derivative will be formed. Relative ease of substitution of various hydrogen in tertiary, secondary, and primary are like for the chlorination, that one is in the ratio of 5:3.8:1, and in case of bromination 1600:82:1.